Okay, so this is an example. This is a different unknown than what you guys have. So this is unknown number one. You guys, I think, have number two. Your numbers are a little bit different. Okay, so just keep in mind that my volume's a little different, temperature is a little different, so the partial pressure is different. But I'm just going to show you an example of how to work on a problem like this. We're not going to do anything of this part. So we don't have any time, and we don't have any current thing. So this is all you don't have to do it. So NA, okay? With that said, that means we don't have to do current stuff. So none of this second table you need to do, like you don't have to do any of this, okay? All we're gonna do is just figure out the steps here, and we'll get to the mass of metal dissolved, and we'll get the molar mass, and that's about it, okay? So let's take a look here. Now, this example here is, you know, it has experimental error, so let's just give and take here. And you'll see the molar mass here doesn't really quite match a metal, but you don't have to worry too much about that. So let's see here what you want to do to get your answer here. So number one, you have to get your volume of hydrogen. So your volume of hydrogen here is going to be basically your volume over here. So technically it should have been recorded as 0 here and 50 here because of the way that was set up, but you guys were given data where your 50 and 0 are here. So basically whatever the value is, I think yours is like 8.8 over here. So just take the difference of that, that will give you the volume of the hydrogen. So basically this is a gas trapping reaction. You're gonna do a reaction which generates hydrogen gas and you trap the gas inside a burette. It's kind of cool. Like the burette is at first filled with liquid, and then when you push hydrogen gas through it, the liquid gets pushed out. So it's kind of cool. Basically collecting gas underwater. Okay, so when you collect gas underwater, you have your volume here and you need your pressure. You remember from Chem 1, we learned that the total pressure, which is the same as atmospheric pressure because you equalize it, and then you have to subtract the pressure on a water vapor depending on the temperature. So depending on this temperature, the water vapor pressure here will be different. But to get the pressure of hydrogen by itself, which is a dry hydrogen gas, you would take this minus that. So that's where our calculation would come here for a partial pressure. So we're going to show you guys that stuff. So in this case here, we'll take a look here. So the volume is 50 and 0, the difference, so it's 50 mils for me. You will get a different value, obviously, okay? So turn it into liters, it will be 0.0500. Okay, so I have that. Now, partial pressure, remember, is 760 minus 23.765. For me, whatever your pressure of your water vapor is, you just subtract it from your original, whatever they gave you, okay? So in the end, in my case here, I'm gonna get 736.235. And I think this was supposed to have another 0 over here. Okay? Now, how do you convert millimeters mercury to ATM? You divide by 760, remember? So this ATM will be a little bit less than 1 because 760 is 1 ATM. So you take 736.235 in this case divided by 760, you get your ATM. In this case, you get 0.96873. Okay, so a whole bunch of numbers here. And then you have this ATM here. Now, how do you get moles of hydrogen? So this is where you start to go PV equals nRT. So we'll do, to get the N here is PV over RT. Okay, so the pressure is that value. We just calculated. So the reason why we have to convert is because we need to get in the correct units. So 0.96873 ATM. Volume is 0.0500, and then R is R was gas constant, so it was 0.08206 liter ATM moles Kelvin. So temperature must be in Kelvin. And temperature in Kelvin, you can convert your temperature. I have 298.9. And then you get your moles here, okay? So this is moles of hydrogen here. So I get 0.001981 moles of H2. So if I know that that's the case, so hydrogen and metal is going to be 1-to-1 mole ratio. So I get my moles of hydrogen, moles of metal, same number. Okay, now and then we have moles of mass of metal dissolved here. So to get the mass here, what do? All you have to do is take your mass from earlier up here. You take 2.0100 minus 1.7608. Then you get the difference. You know that they lost some mass. So the mass of metal that was dissolved, in this case, this minus that, you get 0.2502 because you take this value minus that value, okay? So once you have your grams and you have your moles, all you do is take grams per moles to get the molar mass, okay? So that's all you do, and you'll end up stopping here. Once you get the molar mass, your answer will give you a cool metal. And this one has quite a bit of experimental error, so you can't actually get the correct identity over here. But that's where you end up stopping. You don't have to go further with this experiment. You don't have to do anything of the current calculation here. Okay, so hopefully this helps. This is the stuff you'll end up needing for your results section. So remember, to get the molar mass, you just take the grams divided by the moles.